Hello and welcome to this online event. My name is Carl Spalding. I'm going to give you a quick corporate overview of Graitec. Start off with our mission statement. So who is Graitec? What are we about? Graitec is a global AEC solution specialist and developer. We provide dedicated localized BIM software, technologies, expertise and services to maximize productivity, efficiency and performance across the entire structural industry. Let's take a look at some key facts. So Graitec have been going for over 28 years, which makes us one of the longest standing independent software developers in the structural industry. We have over 200 employees worldwide, 40% of which support our research and development team. We have key subsidiaries around the world, and where we don't have an office, we have a network of resellers, all of which support our 40,000 plus users worldwide, delivering an unprecedented 5 million plus projects. In a time of austerity, it's pleasing for us to report that we've had an exceptional growth over the last 5-7 years, and that's testimony to the technology that we provide, but also the services and the value that we deliver to our customers. Graitec are also one of Autodesk's largest ISV partners, independent software vendors. This means in addition to our own technology, our analysis and design solutions that we develop and deliver globally, we also develop applications on top of Autodesk's leading BIM solutions such as Revit and Advanced Steel, allowing us to deliver exclusive services worldwide. Now let's take a brief look at some of the projects our customers have used our technology to help them deliver. We have commercial structures, buildings, hospitals, fire stations. We've got ice rinks, schools, stadiums. Another area that we're particularly strong is in the oil and gas, offshore, petrochem, pharmaceutical. We've got a good customer base in the material handling and mining industries, towers, cranes, quarries, and of course we're very strong in bridges. We've got our own analysis and design software in there, as well as the steel software to deliver the detail, plate work and boiler making as it was in those days. Mezzanine floors is a big area where distribution centers are popping up, large warehouses, but also to make space in areas you've already got. Miscellaneous stuff like stages and bus shelters and stations. We've got very strong customer base in the architectural metalwork, using our technology to create some very iconic projects indeed. BIM is very much in the detail, and it's important to understand that workflow. So here's a good example. On the left-hand side, you can see the analytical model. In the middle, you can see what we would refer to as a descriptive model. And then on the right-hand side, an as-built or detailed model that could actually be used to construct the project with. Taking that one step further, if you take a slightly closer look, you can see the analytical model is a stick frame. The descriptive model would include other services, perhaps a ground model as well. We're not showing that in this example, but it would bring other industry or disciplines together. And then on the right-hand side, you can see hand railing right through to the base plates, nuts and bolts. So to break that down, you've got function, optimization of the structure, design of the structure and proof that it works, through to describing how the services come together, coordinating different disciplines and sharing that information. And then on the right hand side, the fabrication, the build, the management and connection of that through the phasing and lotting and so on. And in this particular example, we're looking at the interoperability and the sharing of an intelligent model between Advanced Design, Revit, and Advanced Steel. Taking that one step further, of course, we're not limited to just one type of technology or industry type. And here's some examples of some of the technology that we integrate with, looking at the structural industry, but also looking more into the manufacturing, plant, process, and of course some of the coordination and collaboration software and mobile computing with Autodesk 360. I hope that overview was useful, allowing you to understand more about what Graitec offer and the technology and services that we deliver. But now that's enough for me. I'm going to hand over to our technical engineer to continue with the demonstration. Thank you.
Hello, my name is Kevin Fox and I am Technical Manager here at Graitec UK. I'll be showing you this, I'll be taking you through this BIM presentation. To start with, we are going to start a job in SuperSTRESS. Now of course you can start a job many ways. In this example we are going to import a DXF file which could have been generated from AutoCAD. But of course you can start with a blank job through our wizards or through any other means, importing BIM files from other software packages. So I'm just going to add in a few sections here and take you through some of the basic functions of SuperSTRESS. We're going to add in additional bracing onto the model that's been imported, just using the graphical view that SuperSTRESS has to offer. And once we're adding that bracing in, we'll then be able to add in some loading and some support, some more analysis options. So we're going to have some bracing on the columns as well. We're going to create cross bracing, so I'm going to copy all of those by just using a filter through the selection option there of the specific section type that we've added in. So you can see it's very easy to use and very easy to build up a model and make modifications to a model very quickly in SuperSTRESS. So that's the bracing done. We're going to now add in some fully fixed supports along the bottom, again using the graphics, and put in some basic loading. The first type of loading we'll be doing will be self-weight, and put that on the whole of the structure. And then we're just going to analyse that. Obviously you can do more loading if you need to as well, point loads, line loads. And we're just going to show the analysis results on the screen. This is just showing the bending moment on the structure. We can isolate parts of the structure to show just parts of it with the bending moment detail on there if you prefer, and we can isolate the whole structure down to just show that area that we've selected. We can then save views and of that detail and include those in a report. So we're just going to create a new report and put in some sections, some of our results filtered down by this selection I've created, the structure set, and include the view I've just created as well. So there's some tabular data and then the view. Okay, so we're just going to go back to the main model, and now we are going to export this as a GTC file. This is our internal file type that Graitec uses, so that's exported the GTC file from SuperSTRESS, and I'm going to bring that into Advanced Design. So you can see it's a GTC file just imported straight from the SuperSTRESS model, and it comes through as you see the model in SuperSTRESS. So the additional bracing is on there, all of the sections would be on there, all of the supports, the loading, everything we added from the original model comes through as is. So Advanced Design has more advanced functionality, and we can do additional options here like putting in some cold rolled sections, which we're going to change the purlins to, and we can also just get those changed, and we can also change the orientation of these and the eccentricity. So you can see at the moment they're not orientated. We're just the eccentricity is not set, so we're just going to change the eccentricity, and we're going to now just isolate the purlins. You can see we've got the same filtering options that's available in SuperSTRESS, in fact a little bit more powerful in Advanced Design. We're going to change the orientation of them so they are sloping towards the points I added previously, and the same for the second span, and then you can see that these are now orientated towards the centres, and we can change the eccentricity of the main members as well. All covered by the properties on the right hand side there, so everything is consistently modified or added through this properties window. We can even add on haunches and on both sides. And then we just display the whole model. And select some more bracing to copy down. As you can see, it has the same CAD functionality that you would expect, and it can be and you can use the snaps there just to copy members down. We're also going to create wind walls, which are areas of the structure that we defined an area of a side, and then we can actually load climatic loading onto that side. So we've created a new group for that in the systems there previously, and we're going to create all of these very quickly just by snapping around the structure. You can see you've got the same AutoCAD snap functions as you would expect, and we can do the very quick copies as well from one span to another. And then finally finish off with the end bays. So I'm just going to copy those round and then copy them from one side to the other. Okay, they didn't actually go into the system, but I can very quickly select them and just drag them into the system, so they're now grouped in the system and can be hidden or isolated afterwards if you prefer. Okay, we'll just show the rest of the structure. Now we put on some additional loading. We've already got self-weight on this from the SuperSTRESS model, so we're going to put on some snow and wind. For the snow, obviously I'm going to select from a map. We can select a part of the country, and it automates the snow loading, which you can see there. Okay, exactly the same principle for the wind. Obviously you need to be aware of the Eurocode 1 properties that are set in the properties window there to make sure that you understand what is being asked, but the automatic loading can take care of the rest. And same for the combinations. These are created automatically based on whatever we're choosing, so we can place those in and get it to automatically generate. So we're now going to calculate the structure, analyze the structure, and have a look at some of the results. So you can see the meshing has been done automatically. There aren't any plates in this particular job. If there were plate elements, they would be meshed as well. So that's now finished, and we're just going to show some of the results. So we've got all of our basic loads and combinations there, so we can show displacements on the whole structure. We can turn off the mesh just so it's a little bit clearer. We show forces just like we can in SuperSTRESS. There's our bending moment. We can do exactly the same principle that we did in SuperSTRESS by isolating the centre bay and show just the force on there. So going back to the whole structure, we are now going to put on some connections. So we can place on a base connection, make it fixed so it follows the same as the support, otherwise we would have had a warning appear to say that this is not the same type. And we're also going to place on a beam column haunch connection. And we can now go through to Advanced Design's Still Connector program, where the support will come in, the connection will come in, and we can then follow the detail of the connection and in fact carry out a design of that connection. So here's the connection come through. As you can see, we do need to make some changes. Some of the bolts need to be moved slightly, so we can change any of the elements in here. You can see from the joint design aspect, all of the loads that come through from from Advanced Design. We're just going to change some of the bolt positioning to make everything fit correctly. And you can see anything you change in this dialog happens live on the model behind. So now we're just going to run the connection check, and everything is okay, which is great. So we'll have a look at the report, and we can get from here a very detailed report showing all of the checks according to Eurocode 3 for the bolt spacings and design aspects of that connection, which you can obviously then include in a report. So we'll save that connection, and we'll go back to SuperSTRESS, to Advanced Design, sorry. And then what we can then do is export the whole job as a GTC file again, but now with the additional information on it that we've added in Advanced Design, and bring it in to any other program. So for example, we're going to bring it into Revit, straight from Advanced Design, and the model comes through. See, Revit doesn't really have the intelligence to be able to display the haunches correctly, but that's a limitation on the Revit side. But everything else you can see has come through exactly how the model showed, and it will include the loads as well. So if we look at all of the views in Revit, you can see that everything is correctly updated and aligned, and the levels are in place. Orientation and eccentricity of the members is there, and in fact we even have a analysis model created underneath. It's created families on the fly as it comes in automatically, so you don't have to worry about associating families. They have been created or assigned for you if they already exist. So what we're also going to do is bring it in to Advanced Steel for the steel detailing and fabrication drawing production. So again, importing it directly, but this time, as you see, it comes in with the intelligence that we already created with the joints and the haunches. So those have come through automatically, but we can obviously add more. So I'm going to add an apex haunch onto here, and we get the very similar dialog that you saw from the Advanced Design Steel Connection program, and we can make modifications in exactly the same way. And as it's come through from Advanced Design, all of the loads came through with the GTCX file, and so we can carry out a design based on the analysis previously done. So that you can either do this in Advanced Design Steel Connector, or you bring it straight through into Advanced Steel and design the joints there. So just going to put on another single purlin plate, just to show some more functionality of Advanced Steel and how easy it is to add on connections and joints. So the same as with the Advanced Design Steel Connection program, this dialog updates on the fly as we go through, so we can make any changes, they appear instantly on screen. Okay, so now we're going to create some drawings from this. So we've got a vast template of different drawing styles, so we're going to create some detailed drawings, assembly drawings, and GA drawings, just to give you an example of what you can create very quickly from Advanced Steel using the Quick Docs functionality. And we also can create bills of materials and lists, and NC files can be exported from Advanced Steel as well. So there's a GA just being a 3D GA being created. And obviously any changes that happen to the model, these drawings will be updated automatically, and those changes could come from Advanced Design, which I will be showing in a second. So I'm just going to create some lists, material lists, It's worth mentioning, even though we're not showing it here, exactly the same principle can apply to our advanced concrete program, whereby you can export a job with concrete elements, beams, columns, slabs, into advanced concrete, and they will be displayed in exactly the same way as you see here, and then you can do the reinforcement detailing in advanced concrete. And you can also take that exact same job through to Revit and any other program that may accept those objects. Okay, so now you can see there's a document manager where you can view all of the documents created, and they're all directly linked to the model. And our bills and materials, our bolts and anchor list, and our material list. So if we go back to advanced design, what we can do now is make some changes. So I'm going to copy this bracing from one bay to another and change the section property of this column. So we'll change it to a smaller type section. And then what we can do is we could obviously export the whole model, but to make it simple we're just going to export the changes here. So I'm going to create another GTCX file of the changes made, and we can then synchronize these changes. So it's saying export only the current selection, yes. And now we can go to Revit, and in Revit we can synchronize with the original model that we brought in. So we go to the synchronize option and load the changes that we made, the file with the changes that we made. Obviously detects these changes, so there are 2 additions that it's found, so we'll accept those. That's the 2 bracing elements. And you do have a revision tracking option there if you wish. And we're also going to synchronize the modification that we made to the column. So we can close that down, and you can immediately see the changes that have happened, and that is now the smaller type column, and the additional bracing has been added. So very easy to update with changes that are made, and the same workflow follows in Advanced Steel and any other program that can synchronize with our GTC files. So we're going to synchronize with Advanced Steel, the Advanced Steel model. Load up again the changes file and accept those changes that have taken place. Slightly more intelligent on the Advanced Steel side is that any joints that are associated with the members will automatically update. So here we did change the column, and when we accept that change apply that change, you'll see that it's actually going to ask, do you want to update the joint associated with it? Yes, we do. And so that would update, and any drawings associated with that will also update as well, and the whole model. So you can see there that it's the new section type. Okay, thank you very much for your time. If you would like any more information, please contact Graitec UK on the number and email you can see on the screen now, and please also visit our YouTube page where you can see more videos of the different programs: Advanced Design, Advanced Steel and SuperSTRESS. Thank you very much for watching, and goodbye.